In this problem, it's a classic distance problem. And distance problems start easy. Whenever you're doing a distance problem, use this basic equation that we call the distance equation, which is distance equals rate times time. And the main thing to know about this equation is that the rate has to be in terms of the units of the distance and the time. And so if you're talking about miles per hour as your rate, that means your distance is in miles and your time is in hours. If you try to put in a value for distance or time that is not miles or hours, then you're going to get yourself in trouble. So we just need to remember that. The second part about this is a lot of times it's not as easy as just plugging in the three values because you have to add distances together. And that's the case in this problem. It says Paul and George are sprinting each other from 36 miles apart. And so what's happening is you got Paul here and you got George here, and they are going towards each other, and the total distance between them is 36 miles. So what's going to end up happening is the distance of Paul plus the distance of George is going to equal 36 miles. Well, that gives us two variables, and so we got to figure out a way to undo that a little bit. It says if Paul runs 3 miles per hour slower than George, and so we can say the rate of Paul, it says Paul runs 3 miles per hour slower than George, and so if we add 3 to Paul's rate, that's going to give us the rate of George. Now notice I'm using subscripts here, which I think help quite a bit. R of P means rate of Paul. RG, with the G being kind of as a subscript, means the rate of George. Now we got to know something about time, because distance is a rate times time, and so this distance of Paul is going to be the rate of Paul times the time of Paul. Well, it says they run into each other after 4 hours. So the distance for both of them is the same, which makes this problem a lot easier. So you could think about it as the rate of Paul times 4 plus the rate of George times 4 equals 36. Rate times time is essentially what we're doing there. And so that's where our equation comes from. But we need to connect them somehow, and the way I connect them is knowing that the rate of George is actually equal to the rate of Paul plus 3. So just to rearrange a little bit, 4 rate of Paul equals, well, instead of rate of George, I'm going to write rate of Paul plus 3 equals 36. Now this is just an equation I can solve. 4 rate of Paul plus 4 rate of Paul plus 12 equals 36 when I do the distributive property there. Subtract 12 and add like terms, I get 8 times the rate of Paul equals 24, right? I just subtracted 12 here to get 24. So that means the rate of Paul is 3 miles per hour. And so the rate of George is 3 more than that, which is 6 miles per hour. So the correct answer to this problem is 6 miles per hour. Again, when you're doing these, there's always a couple things going on. A lot of times you're going to have some sort of equation that's going to relate multiple distances. And then whenever you got those distances, you need to think about the distance in terms of rate times time and rate times time. And then you need to try to somehow whittle the problem down to where you only have the one variable, like I did in this case of the rate of Paul.